Well, hello there. This is KP the Math G, and I want to just tell you I appreciate you tuning in. I've been noticing that several people have been tuning in, and we've got a few more subscribers. That's really encouraging, and I do appreciate that. I appreciate your confidence in me, and I've had to work really diligently to get where I'm at now, and even though I've been retired, I still study this, and I just love calculus and love math in general. We want to talk a little bit this morning about this afternoon rather, about a 2004 question. It was question 5, and this is the function that's given to describe this. And of course you can see I've already have the graph drawn, and I have actually the areas under each curve given. Alright, and from the previous lesson you saw how I got these answers here. And I don't believe maybe this video, but I do want to show it in the next video. We want to look for the I want to say the absolute minimum, and I want to show you how this is used a lot. Well, we are going to use this, and I don't know if we need these numbers, but I'm just left them up there just in case we do. Okay, all of these different areas. So what I want to do first is I want to find, alright, so I'm going to be working in this little area here. Let's let me find a marker here. Okay, I want to find G prime at X. Now, that is taking the derivative of this definite integral, isn't it? So what I'm doing here is I am finding, okay, this means find the derivative of this. Alright, so I'm going to find the derivative from -3 to x alpha t dt, and I want to find that derivative of that. Alright, this is actually either the first or second fundamental theorem of the calculus. It depends on the book that tells you which one is the first and which one's the second. There are two fundamental theorems of the calculus, and the derivative of the definite integral is definitely one of them. Okay, and so it actually means that you're just substituting f at x in this particular case. If we take the derivative of a constant, okay, that is 0, so we don't worry about that part of it for that simple reason. Alright, it's actually f at x, and so really this whole graph is L. This whole graph is L. It's defined as G, but when you take the derivative of G, you have this, what you're looking at now. Alright, so that's L at x. Okay, so if we had to find, for example, G prime, let's see, I've got 4 of them that I'm looking at. Alright, 5 I think. Alright, so let's do that. So G prime at -4 is the same as saying F at 4. We just said that, I mean, this is G prime right here, and then I got to squeeze that in. G prime at x is equal to, well, it's equal to F at x. Okay, so all I'm doing is looking at F at, in this case, -4. So f at negative 4 is, well, it's 0. You're just reading the graph is all you're doing. Because if this is a function of f, and f is g prime, so we're saying if you are taking the AP exam, you need to say that g prime equals f. Okay, I think they are saying that you need to show that right there, that g prime does equal f. If you want to say g prime at x equals f at x, either way you're saying the exact same thing here. Okay, alright, so g prime at 4 is same as f at negative 4 here, and that is 0. And that's really all you have to do to this. I'm going to just leave this alone and just keep plugging in. Let's see, we can pick any number we want. G prime at negative 3, well, alright, g prime at negative 3 is, already know, it's 2. Alright, so that is f at negative 3, which in this case is 2. That's all you're doing. You're looking for the y value, that's it. How simple is that, isn't it, right? Okay, so just, for those of you who are taking the AP, you may have come across this, and if not, if you've just taken a regular calculus class, they may teach this. I don't know that, but this may be what is being taught today as well. So we're going to go over all of it. Okay, g prime at 0 is the same as f at 0, and that is equal to 1. Well, you see how that is easily done. So all you got to do is plug that number in, just find the y value. It's that simple. But I did want to show you this, that when you take the derivative of this, you just get f at x here. Now, had this been, say, 2x, you would have said, if this had been, for example, 2x up here, and then they would have said, okay, well, it is f at x, and actually, in the first one, without the 2 here, okay, it's f at x times the derivative of x, but the derivative of x is 1, so that leaves us with f at x times 1, which is just f at x. And this whole function is f anyway. Alright, but if they had said do f at 2x up here, if you had a 2x, then you would have had to say f at x times the derivative, times the derivative of 2x, which is just f at x times 2, or we would just say 2 f at x, like that. Okay, so that's the idea, and then you could have still found some values, but you would have had to multiply everything by 2. Okay, and that's the way that works. Okay, and that's how you do that. Alright, so we don't have a 2 there. That's all we had to do. Just to understand that that equals f at x. Okay. I want to touch on another thing. I'm trying to, you might say, kill 2 birds with 1 stone. Alright, so let's leave this up there. I might want to erase this also. Try to get as much off as I can. There we go. Alright. Now I want to do one more thing, since this video is kind of already short anyway. I want to try to lengthen it just a little bit. And the question is, it says find all values of x. We want to find all values, alright, of x from -5 to 4, of course. I don't want to, where g is a relative Let's start with minimum first. Well, we could do, yeah, minimum. Alright. If you're looking for a relative minimum, it's going to be between some number's going to be, if there is one, if we even have one, it's going to be between -5 and 4. Okay, you still look at this graph here. Okay. Alright, so what you're doing here, and again, if you're looking for a minimum, you still got to take the derivative of g. Alright, so you got to show that again. G prime is equal to F. Well, that's what we got here is F. Anytime you've got an equation up here, or you're trying to find a relative minimum or relative maximum, you got to take the derivative of g. All right. So we're still stuck with F. So all right, everything's good. Got to show this, okay, as usual. All right. Again, you could say g prime at x is equal to F at x, and this is what this is, F. All right. So I want a relative minimum. Okay. Let's see. To find a minimum, we're looking for places where the graph intersects the x-axis. Alright? And what we're really looking for is, if it's a minimum, it's going to be a kind of like this. This is going to be where the vertex is a min. Okay? What's happening here? This function, let's call this function, say, h. This function h is decreasing, or it's going negative. And when it gets to the min, the slope is equal to, or m is equal to 0, right here. Alright, and then here the slope is greater than 0, it is increasing. So we're looking for that part, if it's a relative min, where the graph is decreasing, and then where the graph is increasing. We want the slope to be 0. There are 3 places where the slope is 0, right here. Where it crosses the x-axis, that's where that slope is 0. Now, minimum on a graph like this, a min is always going to be below the x-axis. All right, it's got to be this side has to be below. All right, the negative is always below. The positive is always above. Above the x-axis. So we're looking for something that changes from negative to positive. We start off looking for something below the x-axis and something above the x-axis. So it's going to change signs from negative to positive. Okay, you got that? It's got to change sign. Okay, so let's look for things below the x-axis. I see something here below the x-axis, and I see something here below the x-axis. Okay, but it starts off from left to right. If I read it from left to right, this is starting to be negative here. I gotta get some other black or some other color. This black is fading on me. Alright, below here, this part right here, I don't want to circle it because I need it for my next lesson. This little part right down here is below the x-axis, and this part, here's 0, here's the slope equal to 0 right here, and then this is above the x-axis, which means that it's increasing. The F is increasing. Okay, so that's what we're looking for. All right, so F is decreasing below the x-axis. The slope is 0. It's above. This is the place right here where we're going to find a relative minimum. So a relative minimum at x equals -4. Now, what about this one? right here. This, I know, but now as long as it says it's decreasing, increasing, no, you got to look at it above the axis here. All right, so all of this is above the axis. So this part, F is increasing. It's above the x-axis. There's slope. The m is equal to 0, and it's still above the x-axis. There is no sign change, and because there is no sign change from negative to positive, we do not have a min. So there is not a min at x equals 1. Here's another place here, all right? But this one, if we read it from left to right, this part from here to here is increasing. The graph is increasing, and then it's decreasing. Here's the slope m equals 0, so increasing, the slope is 0, decreasing. This is probably going to be where a max is. Maybe a relative max, maybe it's going to be an absolute max. And this could be a relative min or an absolute min, which I could show you that in another video about absolute. But we're just looking for relative minimum. Alright, so a relative minimum is going to be where, if you read it from left to right, this graph is decreasing, the slope is 0, the graph is increasing. It's above the x-axis. Alright, this is below the x-axis, this is right at 0, so this is above the x-axis. It's doing this right here. This graph from -5 to -3 is decreasing from -5 to 4, to -4 rather, and then increasing from -4 to 3. So right here, this x right here, I know what it is. X is -4, okay, and then to the left of -4, it's decreasing, and to the right of -4, it's increasing because this part is below the x-axis and this part is above the x-axis. Okay, you have to think above or below the x-axis when you think of maxes and mins. Okay, that's how you have to do that. Okay. All right, so we have a relative minimum at x equals -4 because the signs change from negative to positive. All right, and actually I have that right here. This is the actual, oops, I'm sorry, 2004 test, and I'm going to read off their answer to you. Okay, they do ask for a relative maximum is what they're asking for. I asked for a relative min. Okay, so this is where the relative min is. So you can guess that the relative max is right here at x equals 3. All right, so let's see. At x equals 3, we have a relative maximum because signs change. All right, the signs change. Signs change from positive, here's the slope m is 0, to negative. The graph is increasing to this point right here, x equals 3. This is x equals 3 right here. Alright, so changes from positive to negative. Okay, and that's what it says. G has a relative maximum at x equals 3. This is the only x value where G prime equals F changes from positive to negative. And you might want to just say the word positive to negative instead of plus to minus. You might could get away with this, I don't know. Okay, but you have to show that you got to show this, and you got to show this, and you get the full. I think that's 2 points for that. Okay, so they asked for a relative max. I gave both a relative min and a relative max, but notice the difference. There is the similarity is there's got to be a sign change, but for a minimum it changes from negative to positive. Okay, there is a sign change here, but this is from positive to negative. Alright, so F is increasing, okay, to the left of 3, and F is decreasing to the right of 3. In this case, F is decreasing to the left of negative 4 and increasing to the right of negative 4. I mean, you could probably say it like that and be okay with that. So anyway, we've done a couple of things. We found out where, what G prime at x is. We found out what, say, G at F at negative, or G prime at negative 4, which is F at negative 4. F at negative 3 is negative, is 2, the y value. F at 0 would be 1. F at 2 would be 1. F at 3 would be 0, and F at 4 would be negative 1. And that's pretty straightforward and simple, isn't it? Then we found all values of x where G is a relative minimum here. Alright, and then we found where it's a relative maximum. Okay, in our next video, we're going to look at I want to say probably an absolute minimum, maybe an absolute maximum, I don't know. We'll do one or the other. I'll show you how to do that in the next video. Please subscribe if you haven't done so already. We appreciate that. If you don't want to subscribe, that's okay. I appreciate it. I just want to be able to help you understand this better. And then, of course, if you want to put a like there, like those are good. If you want to make a comment, please do so. You can make a comment on what I need to do better, or you can say, hey, well done, thank you, KP the Math G. Alright, so anyway, I appreciate everyone. I really do. I don't take this for granted. I really do appreciate you. And that's why I make the videos, because I want you to stay on top of this and learn something from it. Alright, KP the Math G signing off. Have a great day.